Ochoa. He is the Senior Security Consultant of Core Security Technologies. Mr. Hernan has been working for Core Security Technologies for the last 9 years and has written a full-blown antivirus software mostly used to detect and remove Latin American viruses in '98. He participated in the research, design, and development of a multi-operating system security suite for a bank supporting DOS, Novel, Win31, Win95, Win98, WinNT, and wrote device drivers, intermediate drivers, and programs to hook syscalls. He was also involved in the creation of the Core Impact product and wrote several modules for it, including modules to inject impact agents on process in runtime, fake SMB server to capture credentials, etc. And he's currently actively working as a security consultant, doing pen testing, reverse engineering, black box security auditing, web app pen testing, source code auditing, and many more. His presentation today, Pass the Hash Toolkit for Windows. Join me in welcoming Mr. Hernan Ochoa.
Okay, hello everyone. Thanks for coming. Well, like I said, like Amy said, my presentation is going to be the Pass the Hash Toolkit for Windows, and I'm going to be talking about what is the Pass the Hash technique. I'm going to do a brief description of what the technique is and the current implementations and limitations of these implementations. I'm also going to then move on to explaining what actually is the Pass the Hash Toolkit for Windows. I'm going to give you a brief history about how I actually brought the tool. I'm going to give you a description of the tools and advantages that these tools have compared to current implementations. I'm going to also give you some technical details on how the tools were actually implemented. That these details will give you some insight on how actually to use the tools. And I'm also going to describe some post-exploitation techniques that you can perform using the tools included in the toolkit. So I'm going to start by describing what is the Pass the Hash technique. Well, as you all, I'm sure you all know, Windows do not actually store the clear text version of the password of the users. Instead, it's stored two types of hashes of the user's password. That is the LM hash and the NTLM hash. So the Pass the Hash technique is basically a technique that allows you to use those hashes to authenticate to a remote host instead of using the clear text password, saving you from having to actually brute force the hashes to obtain the clear text password. This is a technique that was developed in 1997 by Paul Ashton, that was a member, or is, I don't know, of the Samba team project. I'm sure you also know that the Samba team is actually a project where they implement an open source version of the SMB protocol, that is the protocol used by Windows boxes to provide file sharing services and other services such as remote execution of procedures and things like that. So this technique is based on how the NTLM channel response authentication mechanism works. You can see a basic diagram and an oversimplified diagram of how this authentication mechanism works. Basically, when a client wants to access some resource that is shared by a server, for example, a shared folder, what it does is, of course, has to authenticate first to the server. And it does doing that mechanics. It first connects to the server sends back a random challenge. The client then applies a function F, we don't care about that function right now, using the random challenge sent by the server and the NT and NTLM hashes of the user's password. Then the server, once he receives the result of applying that function, does the same thing locally, and if with the hashes that it has stored for that particular user that is trying to authenticate, and if the responses match, that means that the client has the proper credentials and access is granted. If the result does not match, of course, access is denied. So basically what Paul Ashton said, okay, the secret in this basic channel response mechanism are both hashes, not the clear text password. So if you have the hashes, you don't need the clear text password. How the hashes are used, well, it varies between versions of the NTLM authentication protocol, but it doesn't matter. The important thing to have in mind is that if you have the hashes of the user's password, that is equivalent to having the clear text password, right? So the important thing about this is that this technique is particularly useful because after exploiting a Windows machine, you actually, like I said, get the hashes of the password. So this saves you for actually having to brute force the password. You can just use the hashes to authenticate to a remote host without having to spend time brute forcing the clear text password. So how can you obtain these hashes from a Windows box? Well, after exploitation of a machine, you can run tools such as a password dump that will actually give you the result that you can see in the slide. It will give you the username, and then that one is a number that identifies the user that we don't care about. And the following two byte strings are actually the LM and NTLM hashes. This is just an example. That's why the number is 01, 02, etc. So there's also some other ways of obtaining these hashes. For example, by dumping the SAM database, that is where the Windows actually stores the hashes of the password. You can also sniff the traffic over the network and get the encrypted challenges that I mentioned when I explained the challenge response mechanism. But you actually have to brute force those encrypted credentials to get the hashes that you will be able to use in performing the pass-the-hash technique. You can also do cache dump and several other tools. The important thing is that after exploiting a machine, there are several ways that you can use to obtain the hashes, and then you can use those hashes to authenticate to a remote server without knowing the clear text password. So the original exploit code that was developed by Paul Ashton consisted in basically modifying a Samba client. The SMB client is the tool that is part of the Samba project that is used to actually mount a share that is shared by a remote Windows box. So if you normally use SMB client, what you would do is you just specify, as you would expect, the username and the password, right? This is equivalent as using the netuse command in Windows boxes. So what Paul Ashton did is he basically modified the SMB client so you can provide to the tool the hashes of the password instead of the clear text password. And by doing that, he basically allows you to use these hashes without having to spend time brute forcing the clear text password. So since Paul Ashton published his exploit code, they're having a lot of other implementations of the same technique. For example, there's also a project that is casting of the Samba project that is called Samba TNG that also provides this functionality built in without needing the code that Paul Ashton did. And also there's lots of implementation of the various protocols included in the SMB protocol, written in Python, Ruby, Java, practically on every language. And the technique is also implemented by different exploitation frameworks such as Metasploit, Core Impact, Impacket, and I guess Canvas too, but I've never used it, so don't call me that. I don't know if it has it. So what is the problem with the current implementations of this technique? The problem is that all the tools that actually allows you to perform this technique have limited functionality. That is, they provide you with some part of the protocol specification, but they do not allow you to do everything that you would be able to use to do if you were using a Windows box. Why is that? Because basically what the tools do is, and developers of the tools do to come up with these tools, is they reverse engineer the protocol and then they implement that functionality. That means that the tools are always running behind the current running behind the current newest implementation that is provided by Windows, because they actually have to take the time to reverse engineer the protocol and then implement it. So that's basically a problem, because in some situations when you're doing a pen test, you for example, want to use some proprietary DCOM components that provide you some kind of administration capabilities, but you won't be able to use them because you only can do the pass-the-hash technique using the tools that have this limited functionality. So basically, you can use any Windows tools to perform this pass-the-hash up until now. So what is the pass-the-hash toolkit for Windows? It's basically a set of tools that brings this technique, the pass-the-hash technique, to the Windows platform. It was published in 2007, and it's free and open source, and you can download it and play with it, and it's written in C. And currently, it works on Windows XP, Windows Server 2003, and Windows Vista. It also you can make it work in Windows 2000, but the current implementation does not work in that operating system. So a little bit history about development of this tool. I first actually developed this tool in the year 2000, and I think it's featured in Hacking the Box, in Hacking Exposed, the book, something, I don't know if in the first version of the book or the second, I don't remember. But back then I couldn't publish the code for that tool because it was actually sold by the company that I work for to another company that I cannot mention. Or maybe I can, but I'm not sure about that. so I'm not going to mention the company. But back then what I did do was wrote a paper actually detailing everything that you would need to do the technique yourself. This paper is called Modifying Windows NT Logon Credentials, and you can download it right now and get a sense of what I did back then. In 2007, what I did is I wrote the tool completely from scratch again, and I added some new things that I think you will find useful. So basically, I don't know, this is the first version of the tool had a GUI, and because it was primarily used during presentation and things like that, but the idea was to make it visual so people will actually see it, and it will be appealing for audiences. But at the same time, since it had a GUI, it was not very suitable to be used during pen tests. So what are the advantages of the toolkit? The main advantage over the current implementations is that it provides you with unlimited functionality. That means that since it runs on Windows, every single tool that runs on Windows and uses NTLM authentications, you can use. For example, if you want to use NetUse to authenticate to a remote server, you can use it. If you want to connect to a remote SQL server using the default administration program provided by Microsoft, you can use it. You can use anything you want, because basically what the tool does, it allows you to use the whole Windows box as an SMB client. And also, since right now the current implementation does not have a GUI, you can also use it during pen tests without requiring to have actually access to the GUI of the remote machine, right? So also there are there's a couple of new tools in the toolkit that were not provided with the original version of the toolkit, that allows you to steal credentials that are stored in memory. And if you use this wisely, I hope you will see that later on in the presentation, you will understand that you can use this to actually own a Windows domain more easily. Okay, so now I'm going to give you some technical details about how the toolkit and the different tools in the toolkit were implemented. I think that it will, like I said, it will give you a nice insight into how the tools actually work, and it will help you actually understand how to use the tools. So what is it that we want to achieve? We want to achieve equivalent functionality as the functionality provided, for example, by the patch done by Paul Ashton back in '97 or any other implementation. The functionality that it provides is that you can, instead of passing the password to tools that make use of the SMB protocol, you can pass to these tools the hashes of the password. The idea would be that, for example, if we make an analogy between SMB client and NetUse, the idea would be to be able to use NetUse supplying the hashes instead of the password. But we don't want to be restricted to just one tool. We want to implement it in such a way that it will automatically work for every single tool that runs on Windows. We also want to be able to do this without logging in and logging out, because if you are in a pen test and you are attacking some other machine from your machine, you want to be able to authenticate to several hosts on the network in runtime just by changing the NT and LM hashes that you send over the network, and you also want to do this without having to reboot the machine. And I'm mentioning this because there have been some private things that you were able to do in the past that were not as flexible as this implementation. So basically, how do we go about actually implementing this on Windows? We have to take a look at how the Windows NT logon and authentication model works. There are basically three main components in the Windows NT logon and authentication model. These are the logon processes, that are system components that basically monitor I/O devices for logon attempts. Then you have the LSA, that is basically the user mode process in Windows that is in charge of system security policy and user authentication. And then you have the authentication packages. The authentication packages are the components that actually perform the actual authentication. For example, there are authentication packages for NTLM, for Kerberos, and things like that. They are the ones that create the notion of LSA logon sessions, and they are the ones that associate credentials to those logon sessions. We're going to see exactly what that means. So this is basically I'm putting names on the abstractions that I've just mentioned. For example, taking a look at